Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python. This is the 10th class of a series, classes. Objective of the class today, to learn about object-oriented programming in Python. Motivation. Classes are the foundation of object-oriented programming and also a strong foundation of modular design. Just like we learned about functions in the previous class, we are taking it further by learning about classes. So, classes should be thoroughly understood by the aspiring programmer. Understanding object-oriented programming will help you see the world as a programmer does, because OOP helps to model real-world objects. Content: Introduction to Object-Oriented Programming in Python, creating classes, working with classes and instances, inheritance and polymorphism. Inheritance and polymorphism will look at instances as attributes, various ways of importing classes into programs, styling classes. Learning outcomes. At the end of the class, participants should be able to describe object-oriented programming and some basic terminologies which apply to OOP generally, whether you are learning OOP in Java, C++ or any other language. The terminologies will remain the same. Should be able to create classes, attributes and methods, create and work with instances, demonstrate inheritance, polymorphism and overriding methods or method overriding, import classes into programs in various ways. So let's look at Introduction to Object-Oriented Programming in Python. What is object-oriented programming? It is a process or a programming method of using programs to represent real-world objects, as we will see in this class. So what is a class? A class is a program that represents real-world things. And a class has something called methods, which are codes in the class. Actually, methods are functions inside the class. So every class you create is going to contain methods. Actually, like I said before, methods are functions inside a class. We don't call them functions when they are inside a class. Rather, they are referred to as methods. A class also contains attributes. Attributes are data objects in the class, which are variables, constants, so on and so forth. So generally, a class is an object that has an attribute or a set of attributes and the corresponding set of methods. So let me describe it this way. A human being belongs to the class of mammals, or let's make it simple, the class of humans. They have certain things called attributes. Humans generally have physical attributes that describe them. For instance, they should have two hands, they should have one head, that's a normal human being. They should have two limbs, two legs, and the torso. And that generally applies to the class of human beings, no matter the race you came from. Now, those are attributes which describe the physical structure of the class. Methods are the behavioral structures or behavioral things associated with the class. For instance, there is something common to all humans. A normal human being should be able to talk. A normal human being should be able to see. Human beings sing. Human beings dance. They just hear music and then unconsciously the body begins to move. It's an attribute that is common to all humans. Human beings dance. Human beings sing. Human beings talk. All of those are methods or behaviors of the class of humans. So, when a class is created, you can create objects from the class. In fact, a class is an object. You can create many objects from a class once the class has been created. So we say objects are created based on classes. Like I was describing before, a class defines a general behavior that the whole category of objects can have. Another thing that is common with objects is inheritance. An object that is created from a class is automatically equipped with the general behavior of the class. So new classes can thus inherit and extend the functionality of existing classes. Let's look at it this way. The class of humans. Humans create babies. Those babies are humans. They may be small at birth, but the fact that the baby has been born, the general characteristic of the human race is associated with the baby that is created. For instance, the baby is going to inherit one head, two legs, two arms, and a torso. That's the general characteristic. That is the process of inheritance. The baby has inherited the attributes of the class. That's the idea of inheritance. Not only the attributes of the class. As the baby begins to grow, it starts to talk, like the class of humans. Sometimes the baby is going to, as the baby grows up, is going to imbibe some of the characters, or generally have some of the characteristics of the parents, the specific parents that gave birth to him or her. That is also inheritance. Sometimes the baby will look like one of the parents, maybe look like the dad or look like the mom, or have some physical attributes of one member of the family. Maybe sometimes they have a hereditary disease or something like that. All of those are inheritance. Inheritance also goes further. In some parts of the world, parents like to leave an inheritance for their children. Physical property, so on and so forth. So that is also a part of inheritance. And we see it in more details as we progress. Now, objects or classes have the tendency to exhibit something called polymorphism. So we say, even though a child inherits from a parent, a child can also inherit from both parents. For instance, the father has an attribute, the mom has an attribute. Some attributes of the dad cannot be exhibited by the mom, and some attributes of the mom cannot be exhibited by the dad, and the child picks up both of them. So it becomes like a super object of both parents, and the child can learn other attributes and methods and add it to his own, making him to be able to exhibit different behaviors and attributes from that of the parent. This is the process we call polymorphism. Multiple inheritance is also a part of polymorphism. So let's give an example. There are some parents that cannot roll their tongue, both of them, or one of them can roll their tongue. The dad can roll his tongue, the mom cannot roll the tongue. The mom can twinkle her nose, that's move her nose or move her ear, and the dad cannot do that. So they give birth to a child that can be able to roll the tongue, can be able to twitch his nose, or move his eyebrows, or move his ears, and the child begins to exhibit the mixture of both behaviors. It becomes a super exhibitor, sort of. We call that polymorphism. Now, the process of making an object from a class. You create a class, and you want to create multiple objects from the class. It's like making babies. That is what we call instantiation. So, let's go straight to creating classes. In Python, you define a class using the class keyword. So we'll look at something similar to what we did with functions. We start with the keyword class, and then we give it a name. Then we have a colon in front of it. Nothing else follows. Then something must follow under it. Def double underscore init double underscore self. This one must follow all classes, and a colon must follow it. Now we will describe this further later. And the code suite follows. Everything you have below here is going to be the code suite. So everything that is indented under the keyword class is a part of the class. We have a simple example here, class dog. So we have def init self name age. Self.name equal to name, self.age equal to age. This self.name equal to name, self.age equal to age are all parts of the class dog. The def init is a method, actually a function inside the class. All of them are part of the class. Let's describe it further. The keyword def starts the class definition, and you should give your class a nice name, any variable name. For instance, class athlete, class humans, class mammals, class dog, class sheep. A colon must follow the class name. Def init is a special method that Python runs automatically whenever a new instance of a class is created. Now what you see here are double underscores. The self parameter may be followed by an optional list of parameters. It is compulsory to have a self parameter inside the def init. You can also have an optional list of parameters depending on the purpose why you are defining your class. For instance, in this example of class dog, we have name in addition to self, and we also have age in addition to self. You can have a lot more if you want. So the code of the class, all of them must be indented, as you can see from the example we have here. So let's go into examples right away. We start with the first class. We call it class dog to demonstrate basic class creation in Python. So we say class definition, class dog. Now everything you see here is a comment, a docstring comment, as you already learned from the previous classes. So method init is required and self parameter is required. You can't do without those. So we say def init self name age, our first method. In fact, init is a compulsory method that must be in the class. You can define as many other methods. So parameters initialized with self are called the attributes of the class. So every dog has a name, or most dogs should have a name, and every dog should have an age when the dog was born. So we say self.name equal to name, self.age equal to age. So whenever somebody creates an instance of dog in future, like a dog gives birth to a puppy, that puppy should have a name and that puppy should have an age. So this is what we use this self to initialize right here. So if we define other methods, for instance, if we say bark, generally dogs bark, is it not? So we simulate a dog barking in response to an event. We are going to make this method quite simple, and we just print a message, which is what this method does. Self.name is now barking. You see, these attributes which we created, which we put as parameters in def init, we can use them in any other method that we define in the class. So we just print a message and say self.name is now barking. Now if you want to know how interesting classes are, you may have seen the robotic dogs Aibo. They have to be programmed to perform. So imagine we are using this class dog to represent the robotic dog. It's a program inside the dog, and any person who wants to program it will use this class. So when you define this function bark, you are likely going to write a comprehensive program under it that actually makes the dog to bark, produce the barking sound. It's going to be more elaborate than this. So but since we are not doing robot programming here, let's make it simple. We just print a message that says self.name is now barking. The program continues. Dogs normally sit. So we define another method that is called sit, another behavior, general behavior of dogs. So what do? Make it simple. Print self.name is now sitting. For the Aibo robotic dog, for instance, you are going to write a comprehensive program that moves the motors and make the physical structure of the robot to actually take the position of sitting from whatever position it was in before. Now that's pretty complex. Generally, something like that is what this method is meant to represent. So let's make it simple here. We just say self.name is now sitting. Dogs generally roll over. That is another character of dogs. So we define another method called rollover. And we just say self.name rolled over. Now, after you have finished defining the class and defining several methods for the class, how do you use the class? You make an instance from the class, or you produce a child from the class. And what we do that is we just say my dog equal to, so you use the name of the class dog, and then you put the parameters that are required inside. You don't need to put anything inside self here. Only the other two parameters that were defined in the creation of the class requires arguments. So there was name and there was age. So we are only going to give name and age. Say Willie and age 6. So we say print my dog's name is. Since we have created an instance of the class, we can now access the attributes of the class directly by using the dot. So whenever you are writing a Python program and you call a function and you see a dot somewhere, just know that we are actually calling a class that was created in Python as a part of Python. So we say my dog.name is going to print out the name of a dog, Willie. And when you print out my dog is, my dog.age years old is using the attribute of age. Now, when you want to call the methods, you use the dot, just like the way you use the dot to call the attributes. Take note of the difference between attributes and method. When you call the method, you have to put this parenthesis. That is what indicates that we are calling a method in Python, which differentiates the calling of a method from the accessing of an attribute. You access attributes, you call methods. When you access attributes, you don't need to put the parenthesis. But when you call methods, you need to put the parenthesis. And because the method itself actually has a print statement, it will automatically print for you here. So if you run the program, this is what you are going to get. My dog's name is Willie. My dog is 6 years old. Willie is now barking. So here we are in Visual Studio Code, and this is the class which I just described. We are now going to run the class. Because we don't need to type anything, we will use AREPL. So let's comment out the last two items. After commenting the last two items, we just see the first print. My dog's name is my dog.name. My dog's name is Willie. That's what we get in the output. If we comment out the second line, my dog is 6 years old. And if we comment the last line, Willie is now barking. So we'll continue with the classes. We can modify the attributes associated with a particular instance of a class. We can also write methods that update attributes in specific ways. So let's look at another class. We'll call this class car to demonstrate working with classes and instances in Python. So we say class car, a simple attempt to represent a car. We start again with our def init, and we must have self inside. So let's add other attributes. Make, model, year. We initialize the attributes. Self.make equal to make, self.model equal to model, self.year equal to year. Every attribute or most attributes must be initialized. So we add another attribute that we did not define in the parameter list of the definition of init. So we said self.odometer reading equal to 0. Now this kind of attribute is an attribute that can change over time. You can still access it when you create instances of a class. Now let's go to the methods. The first method is we say get descriptive name. self. What this does is to return a neatly formatted descriptive name of the car. So we give it a variable long name equal to f self.make space self.model space self.year. Return long name.title. So we are returning something. So if you actually look at this method here, it's just a function, is it not? It's just that when you start dealing with object-oriented programming, we no longer call them functions, we call them methods. Let's create other methods. Read odometer. You know what an odometer is in a car. It is that thing that keeps reading how much distance the car has traveled. It is permanent, you can't change it. So the mileage shows there. In future, when you want to sell the car, that is part of what people read to know how much work the car has done. It's one of the factors that determine the selling price of the car. So let's see read odometer. This prints a statement showing the car's mileage. So we say print this car has self.odometer reading miles on it. So we have now accessed the odometer reading attribute of the class. Originally it is 0. So what it is going to print there is 0. Now we can also create another method that actually updates that odometer. In this new method, we don't only have self, we also have mileage. What this method is going to do is set the odometer reading to a given value of mileage that was put inside here. But we are also going to do something else. We will reject the change if it attempts to roll the odometer back. See, we don't want to deceive people by saying that the car mileage is actually 10 miles when it is 100 miles. So we do a test. If mileage greater or equal to self.odometer reading, recall that self.odometer reading is the previous one that was entered when the class was created, or the most recent one when the odometer reading was updated. So we keep checking. If the current mileage that you are asking us to put there is greater than the previous one that is there, then set the current mileage to the new one that you are adding in the method. Otherwise, send a message, you cannot roll back an odometer. So we create a new method called increment odometer. Now what this does is actually increment by adding the new miles value that you are going to put in this method, by adding it to what was previously in the odometer reading. So we do that like this. We just say self.odometer reading, which is the previous value that was there, add it to the current miles that is being added by this method. And that's generally what a car does. See, the car keeps adding mileage. The moment you turn on the engine and start driving, it keeps adding mileage to the odometer reading. The downside is it may not be actually the exact miles that you traveled. Now, take note that we did not call this class at any time. We just created this program and leave it there. So we have a car class. We'll call it in another program. So we want to show how to work with instances of a class. You see, it is not usually inside the code of the class that you created that you call the class. You don't normally instantiate it. You create a class and you keep it somewhere like functions. They are like modules. You see, if you learned about functions in the last class and you thought that functions are powerful, functions do things. Classes are much more powerful. Classes are things themselves. A class contains, one single class contains a lot of methods, which are actually a lot of functions and a lot of attributes. So that makes them much more powerful than classes. So we look at working with instances properly here now. So we have a new class and we are going to call it carinstance.py to demonstrate working with class instances in Python. So we are now going to import class car into our new program. So we say from class car import car. Remember that class car was a Python file, and class car was a class inside class car. So we import it. So we create our first instance of the class. My new car equal to car Audi A4 2019. Print my new car dot get descriptive name. We are calling a method get descriptive name. Then we say my new car dot read odometer. We are calling another method read odometer. Now let's see how to modify an attribute's value directly. My new car dot odometer reading equal to 23. The last value was 0, so certainly the next value is going to be 23 when you modify the attribute directly. The second thing we want to do is now read the odometer, which actually prints out the value of the odometer reading. The class continued. See, our programs are becoming more complex because we are no longer babies in Python. So we call another method, my new car dot update odometer 60. So we do my new car dot read odometer, and what this does is just prints the odometer reading to the screen. Let's see how we can increment an attribute's value through a method. If we create another instance of a car, you see what instances does? We can create as many instances of a class as possible. So when you are shopping in Amazon or another shopping site, can you guess how many people are logged on to Amazon at the same time? They are shopping from the same website. All of them are carrying their own shopping cart around. Do you often wonder why what you put in your shopping cart does not automatically appear in somebody else's shopping cart? Because what they use there is classes. So the moment you logged on, Amazon website has created your own instance of the shopping cart for you specifically and assigned an ID. So whatever you are doing does not interfere with another instance of the class. So we've created an instance my new car. We have now created an instance my used car. We say Subaru Outback 2015. Take note that the moment you created this new instance, all those odometer reading that was modified and everything that has been changed in the previous my new car has no effect. The moment you created this new instance, it created your own fresh, brand new car class. Everything new. The odometer reading of this my used car is 0. Everything is from the scratch. Okay, that is the beauty of classes. So we say print my used car dot get descriptive name, and then we say my used car dot update odometer 23,500. Remember what this is? It is 23,500. In Python you can use these underscores to separate long numbers. It works. So this update odometer reading has nothing to do with the previous odometer reading. This one is for a new instance and it has no business to do with the other one. My used car dot read odometer is going to give you 23,500. My used car dot increment odometer, it now goes to 23,700. My used car dot read odometer is going to show 23,700. So when you run the program, this is what it looks like. The first instance was my new car, Audi A4 2019, and you see the output on this side. This car has 0 miles on it. When you saw Audi A4 2019, it was calling print my new car dot get descriptive name. When you see my new car dot read odometer, this car has 0 miles on it. So we modified it to 23. This car has 23 miles on it. Then we modified it again to 60. This car has 60 miles on it. Okay? So in the Subaru Outback, we actually did the update odometer. That is why it moves from 23,500 to 23,700. So here we are in Visual Studio Code and we are looking at the class car instance.py. So we are going to use docstring to comment out a whole part of the code so that things will become clearer when we look at ARAPL. Now we open ARAPL. So after we do that, we see print my new car.get descriptive name Audi A4 2019. Let's move this down a little bit more. My new car.read odometer. This car has 0 miles on it. So let's do my new car.odometer reading equal to 23, and we put this here. My new car.read odometer. This car has 23 miles on it. The next time we still did update odometer with 60. We did not increment odometer. So because we did update odometer with 60, what we just did was replace 60 with 23, and then it says this car has 60 miles on it. Now let's continue from here. We create a new instance of a car. We call it Subaru Outback 2015, and then we say print my used car.get descriptive name. And what do we have? Subaru Outback 15. So we now say my used car.update odometer 23,500. Then we say my used car.read odometer. This car has 23,500 miles on it. Now we call increment odometer. My used car.increment odometer 200. And then we say my used car.read odometer is going to print this car has 23,700 miles on it. So increment odometer increments what you have in the odometer. Update odometer takes the new value you put there and replaces the previous value of odometer if the new value is greater or equal to the previous value. So let's move on to inheritance and polymorphism. If you want to create a new class, you may not always need to start from scratch. So a new class, which is a child class, can be a specialized version of another class, which is the parent class. Like we said before, a class child inherits all the attributes and methods of the parent class. That is called inheritance. Plus, the child can have added attributes, added methods, which the parent class did not even have. In fact, a child class can inherit multiple parent classes, making it more powerful, like a ninja class, and that process is called polymorphism. So, based on this ability of polymorphism, the child class can also override methods from the parent class. That is called polymorphism also. It's also a part of polymorphism. For instance, a child may see the good behavior of each of the parents and decide to imbibe the good behaviors and drop the bad behaviors. That process is akin to polymorphism. A child class can also inherit attributes and methods from more than one parent classes, like I said before, and this is also a part of polymorphism. So let's go straight to see an example. We start by defining a class called electric car, class electric car, to demonstrate inheritance of classes in Python. So let's begin with just demonstrating inheritance. And we say from class car, import car. Remember, we've created class car before. So let's define an electric car which is a child of class car. Now, this time around, when we say class electric car, we don't just stop at the colon. Rather, we put something in parentheses and put the name of the parent class which this new class is inheriting. So electric car inherited class car. Something else we need to do. We now say def init self make model year. So we need to initialize the attributes of the parent class. Super means we are initializing the attributes of the parent class. We say super.init make model year, which are attributes of the parent class. Now let's begin using instances of the class. Actually, this program is simple. Normally what you should have done is the moment you created this electric car from class car, you put it in its own file and you call it from another file. But since this class we created was just demonstrating inheritance, nothing special, it's still the same class car that we are showing here. We just made the program simple by calling it right here inside the program. So we say my Tesla equal to electric car Tesla Model S 2019, and we can say print my Tesla.get descriptive name, which was a method of the parent class. So here we are in class electric car, which demonstrates basic inheritance in Python. So we look at ARA here and try to see what comes out from the code. It is just class car that we are trying to demonstrate here, how to inherit a class. So if we say print class car, let's modify something here. Print Tesla.get descriptive name. It just print Tesla Model S 2019. Let's look at inheritance and polymorphism in more details. So we'll call this class electric car 1. We want to demonstrate inheritance and polymorphism of classes in Python. So we will define attributes and methods for the child class, new attributes and methods, new behaviors. And then we will also override methods from the parent class, which is also an aspect of polymorphism. So we import class car again, and then we'll create a class and call it electric car. This one is a new electric car entirely, which inherits the parent class. So like as usual, we are going to initialize attributes of the parent class and then initialize attributes that are specific to an electric car. Def init self make model year. Then we initialize the attributes of the parent class super.init make model year. And then we also define an attribute for the new child class, this child class we are creating. We say self.battery size equal to 75. Take note that battery size is not in class car. So we've created battery class in class electric car, which has made it one step more powerful than our original class car. We'll continue. Let's create another method, a new method in class electric car that is not in class car. This is polymorphism. So we say def describe battery self, print a statement describing the battery size. We say this car has a self.battery size kWh, kilowatt hour. We can also override methods from the parent class. For instance, we want to override the method read odometer. This is like a child drops a specific behavior of the parent and changes to a different behavior. So we say def read odometer. Take note that read odometer was also in the parent class. So we are changing it now in electric car. Read odometer self, print a statement showing the car's mileage. We don't want to show the car's mileage, we just say print electric cars are forever. Of course it's not true, it's just for the jokes. Okay? So that only serves to show that we can actually change one of the behaviors of the parent class to what we want in the new class. Now, let's call the first instance of a class. This should have been done in a different class like I told you before by calling the electric car class, but we are doing here for the purpose of learning so that we don't have to create too many files in this class. So I say my Tesla equal to electric car Tesla Model S 2019, print my Tesla.get descriptive name, which is in the parent class. We did not override it, but we'll do something else. My Tesla.describe battery. This is now a new method in the new class that is not in the parent class. And then we say my Tesla.read odometer. This was a method in the parent class, but has been changed or overridden in the new class. So the last two things here are examples of polymorphism. The first one is an example of inheritance. In fact, the last one is also an example of inheritance, but an inheritance that becomes overridden or changed. So when you run the program, this is what you get. Tesla Model S 2019. This car has a 75 kilowatt hour battery. And then when you call read odometer, it shows electric cars are forever. So here we are looking at electric car 1 in Visual Studio Code. We open ARAPL, and let's try to use docstring comment to change some things here. So we don't have an output. Let's see the first print. Tesla Model S 2019, get descriptive name. That was in the original parent class. Get my Tesla.describe battery. This car has a 75 kilowatt hour battery. And the last thing is read odometer. Electric cars are forever, false though. That is method overriding. So the last two are examples of polymorphism. Sometimes in the process of exhibiting polymorphism, you can use instances as attributes. Imagine you use a whole instance as an attribute. So if a class is getting too large, you can break it into smaller classes that work together. Now in that class car.py, the original class car.py module, we can add another class inside there called battery in addition to the car class that is already there. So what you should do is place the code below class car. So we say class battery, a simple attempt to model a battery for an electric car. So we say def init self battery size equal to 75. We initialize the battery's attribute. Take note of something we are doing newly for the first time. We set a default value for battery, is it not? In def init we set battery size equal to 75. So we can now say self.battery size equal to battery size. Then we'll create another method and say describe battery self. Print a statement describing the battery. This car has a self.battery size kilowatt hour. So we can now use the instance as an attribute in another program entirely. Let's call this electric car 2. We are also demonstrating inheritance polymorphism. This time we are also showing instances as attributes in Python. So we say from class car import car. We don't end there. We also say from class car import battery. See, we are now using two classes in the new class that we want to create. So we say class electric car. This is a new electric car class now. We say car. First of all, it inherits the original class car. As usual, you should initialize the attributes of the parent class. We can now define a new attribute for the child class. Instead of doing what we did in the previous program, self.battery size equal to 75, we rather say self.battery equal to battery. So this battery you see here is an entire class with all its methods, all its attributes. We just use it to create an attribute or to instantiate an attribute or to set an attribute. And that is a very, very powerful feature of classes. So we continue. We are now creating instances of the new electric car class. My Tesla equal to electric car Tesla Model S 2019. Print my Tesla.get descriptive name, which is from the parent class car that has not been changed. And then we say my Tesla.battery.describe battery. See the double dot here. Because when we created this attribute battery for the new class, we actually inherited a whole class battery. So that's why the second dot is coming in. We are now using this attribute to call a method from an entire class. So whenever you are working in Python and you see dot here, see dot there, you can have an idea of what is exactly happening in the background. Okay. So when you run the program, this is what you get. Tesla Model S 2019. This car has a 75 kilowatt hour battery. So here we are. Before we go and look at the program that we just described, we'll look at class car again and discover that in this class car.py there are actually two classes. The first class is class car and the second class is class battery. So this class car.py is a module. It's a module that can contain as many classes as possible. Just put all of them inside there. We will now close this now and open electric car 2, which is the last program that we described, and we'll comment the last one out because there are only two print statements. So it says Tesla Model S 2019. Finally, we'll comment the last one, and we'll have this car has a 75 kilowatt hour battery. So there are various ways of importing classes in Python programs. Just like we learned how to import functions, they are basically similar. So we can import multiple classes from a module. Our class car was a module. From class car, import car. Car was the class in the module. Battery was another class in the module. So we can just say from class car, import car, battery, whatever else you want to import. Then we can call and make an instance of any of the classes. My B2 equal to car Volkswagen B2 2019. Print my B2.get descriptive name. We can also import an entire module. Import class car. Every class inside this module is imported. My B2 equal to class car.car. So take note, because we did not explicitly import car, the class car and battery, we only imported the entire module. You need to use the module name to precede every class you are going to call. That's why we have class car.car. We can also import all classes from a module by just saying from class car import star. When you say import star, you no longer need to use class car to precede the name. You can actually call each of the classes directly like we did in the first example, my b2.car. You can also import a module into a module, and you can also use aliases the way we did it using functions. For example, you say from class car import battery as bat. Of course, we saw the advantages of doing that, so I don't need to go over it again. Styling classes. Class names should be written in camel case, not like functions. Take note of the difference. Don't use underscores like functions. It is not a law, it's an admonition, and every other Python programmer who sees your program will understand them better if you follow this advice. Instance and module names should be written in lowercase with underscores between them. Instances and module names. Every class should have a docstring immediately following the class definition. These are not laws, they are admonitions. The docstring should be a brief description of what the class does. Each module should also have a docstring describing what it is used for. If you need to import a module from a standard library and a module that you wrote, like we said before, place the import statement of a standard library module first, then add a blank space before you start importing your own modules. So we've come to the end of the class today. Our bibliography remains the same. Please like, share, comment, and subscribe for more videos. Thank you very much, and see you in the next class.